Okay, so I'm going to focus on even more MOV instructions. So if we just go to the tests, and I'm going to start with these duplicate MOV instructions. So there's MOVDDUP here. This also goes with, I think there's MOVSH duplicate and SL duplicate. These are the same forms as far as I know. So if I do the test for this one, I can duplicate those for the other MOV instructions down there. So let's just start by adding these to the top here. We've got MOVDDUP, and this has, for the legacy, it's only got one form, which is RM. So we'll just go XMM0, XMM1, and then we'll copy this to do the memory access. The VEX encoded versions here are also just two operands, but they support up to YMM, and then EVEX supports up to ZMM with the op mask as well. So we'll just copy this one. This one can change to YMM. Then we'll just take these ones as well, and we'll force the EVEX encoding by doing the op masks, and make another duplicate and change this to ZMM. So let's just go and create the tests for these. And then line them all up. So this looks like it should all be correct. So let's just go and take these two mnemonics here. Maybe we'll just go and find MOV here and just add them to the bottom of these. Then I need to add them to the name table. And then we need the forms as well. So if I just reassemble this listing file and run go test, it can't find a matching form for the instruction. So let's just add that now. So we've got one legacy form here, which is just XWord. The op-n for this is always RM. So op1 can be vector, and then the M operand can be vector or memory. So these have a mandatory prefix of F2, followed by the secondary opcode map, followed by 12 is the opcode. So this has a prefix of F2, the map is the secondary one, and then the opcode is 12. So we'll just take this for the EVEX and VEX encodings. This needs family now, so this is VEX family. The width should be XWord and YWord. And then EVEX can have XWord, YWord as well, but we'll have an extra one here for ZWord. Actually, I think, no, they all support opcode masks, so I don't need an extra one. I'll just put ZWord onto this one. But op1 can now also accept op mask and zeroing. Okay, so we've got a slightly incorrect thing going on here. It looks like it's P0, P1. I think this might be where the W bit is. So we want F. It looks like maybe I'm just missing a W bit being set. Yeah, so EVEX has W is 1. So this is W1. Okay, so those all pass. So that's MOVDDUP. So I can basically copy these tests for MOVSLDUP and MOVHL or MOVSHDUP. Because these are basically just the same forms. They've all got two operands, they all accept op masks, and they all have the same number of forms. So we'll just go to the tests over here and take a copy of these ones. We'll get rid of this test notation over here. So this is now, instead of MOVD, let's just go and find that. So we got MOVD, This is now MOVSL. And then we should be able to take a copy of these and change it to MOV SH. So let's just go and sort these tests out. So we'll add these and then do the transformation. Line them all up. They will look like they should be correct. So let's just regenerate the NASM listing. Okay, so cannot match instruction form, that's fine. So let's just go and find VMOVDDUP. We'll just copy these. Instead of being MOVD, this is now SL. And we need SH. Okay, let's just go and add the forms. So these are actually just going to be more of these. So I'll just copy these. So D here is now going to be SL, SL, SH, and SH. Okay, missing name. Let's go and add these to the name table. Okay, so now we just need to update the opcodes and things. So this looks like it's prefix changes to F3, and then this one changes opcode to 16. So they both use a prefix of F3, but then SH needs 16 as the opcode. W is 0 for both of them. And then we've just got something going on here. For SL duplicates, we've got F3, 0F12, F3, 0F12. That looks like it should be okay. F3, 0F16. That also looks like it should be okay. So what's going on here? It's only for SH that it's incorrect. It's got 12 somewhere. Here it is, this one. Okay, so that's all passing now. Next one will be MOVLPS and PD. So there's MOVLPS. This one has a few different operand encodings, so let's just go and type these out. We'll just put them below here. So there's MOVLPS. So we've got register memory, so this is RM. And then the VEX version of this and the EVEX version of this are RVM. And then the difference down here is that the operands have just switched around. So I'll just do one of these first. So we'll do XMM 0 with memory. Then we've got the VEX version of this, which has XMM, XMM1, then memory. And then we've got the EVEX version, which I'll just have to force by using a high register. Then we've got the other versions, which are just switching around the operands a bit. So the ones with memory in the destination side are actually all 2 operand. Okay, let's just take these, put them on the end, and get rid of these ones. That should be enough. Let's just check that NASM's okay with this. Seems like it's all okay. Okay, let's just, I assume that it's going to be the same for MOVHPS as well, and LPD and things. So it looks like those are all the same. Looks like those are the same as well. So let's just make a copy of these tests. This is going to be MOVLPD. And then we can just do a copy of these to change MOVL into MOVH. Let's just make sure it's all okay. Yep, that's fine. Okay, so now let's generate the tests. I've got an incorrect selection somewhere here. Okay, let's line them all up and do the transformation on this. So they all look like they're all okay. It is just X word here. There's only XMM supported in these, so that's fine. Okay, let's just go and get these mnemonics and add them below here. I'll just deduplicate them and add them to the name table. Then we'll just go and add them to the forms. Okay, so go test should fail here. Okay, so let's start with LPS. So this one is RM, and then the other ones are MR. So we'll do a match on the width of X word. Op_N for this one is Op_N RM. Op_1 in this case can be a vector, and Op_2 can be memory. Looks like it's just memory, yep. Then we've got no prefix for this, but we do have the secondary opcode map. Then we've got the opcode, which is 1, 2. Then for the other way around, for the legacy encoding, we've got 1, 3. And we just switch the operands. So this one becomes MR. Then we've got memory here, and then we've got vector here. So for the VMOVLPS, this is where it gets a little bit different, where the RM or the RVM encodings have 3 operands, and then the other 2 down here have 2 operands, which are still MR. So let's just focus on this. We'll do family is vex. The width is still X word. The op_N for this is now op_N RVM. Yep, RVM. Op_1 in this case can be vec. Op_2 can also be a vector. And then op_3 here is memory only. This one is the same in that it has the secondary opcode map. So we've got map, and then the opcode is 1, 2. But we also have EVEX. EVEX being exactly the same, it's just that it will support things like higher registers. Then we need to change things a bit for op_N MR. So this will be mem and vec. This one has the secondary opcode map, and it's got 1, 3 as the opcode. So then we'll do the same thing for EVEX as well. Let's just do the test and see how that goes. ME should be MR. Okay, so MOVLPS is still not matching. MOVLPS needs to match on X word, This one is RM. So we've got VEC, we've got memory, and it's still not matching. Let's just go and look at the tests again. Xword, memory. That should be okay as far as I can see. MR, that one's not even, we're not even getting to that one yet. So MOVLPS line 42, that is this one. Let's just reassemble just in case I haven't done the tests. Yeah, okay, I just hadn't assembled it yet. Okay, so now it's on to PD, which is fine. So that means that it's going through all of these forms and it's all working okay. So I'll just take a copy of these ones. These are probably going to be roughly the same. So we'll just go here. So these have a prefix of 66. So we'll just add 66 here and do the test. So it's mostly okay. It looks like W bit needs to be set for EVEX. Okay, so now we're on to HPS. So MOVL, is this LHPS or... Oh no, it's just HPS. Okay, so MOVHPS is more of the same, but we've got different opcodes here. So this is 1.6 and 1.7. So let's just take these ones here. I'm sure these are basically going to be the same as all of these, so let's just copy them out. And instead of MOVL, we have MOVH, but I've missed one of them. Let's just go and get them again. So let's just change MOVL into MOVH. This should match hopefully on everything. Yep. So MOVHPS changes from 16 and changes to 16 and 17. And then 13 changes to 17. Let's just see if that did it. Yep, okay, that's all okay. So then we've got MOVHLPS, or MOVLHPS, I should say. And there should also be MOVHLPS up here. So these two are very similar to each other, so I'll just do LHPS first. So we'll put them down here. So this is MOVLHPS. Okay, I think that's it. So these all have RM and RVM as the operand encodings. So RM here, this is not showing any memory here. So I'll assume that this doesn't accept a memory operand. Then we've got V, which is also just registers as well. And the EVEX one, I'll have to use a high register to force. So this will be XMM2 because it's got 3 operands. And we'll do 16 for this one. Let's just go and change these to HLPS. Okay, let's create the tests for these. That all looks correct. Add the mnemonics, deduplicate. I need to add them to the name tables again. And now let's go and add some forms. So for LHPS. There's no prefix for any of these, and we're only matching on X word again. Op-N for this is op-N RM, but op1 and op2 can only be vectors. There's no prefix, but there is a map. And the opcode for this is 16. Same goes for the VEX and EVEX ones. Okay, let's just go and duplicate this and call this EVEX. And these EVEX ones actually need to be RVM. And they need to take an op3 of VEC as well. Okay, and let's just duplicate these for HLPS. So HL, let's just go and look at this. So we've got the same thing, but it's opcode 12 instead. Okay, let's just regenerate the listing and run the tests. Okay, so that all works fine. Next is going to be MOVS. Let's see, where is it? MOVMSKPD, I think. I will start with PS, actually. So this is actually very similar, it's just that it's using a normal register instead of a vector. So we'll just take the tests for these two latest ones. And instead of, actually let's just go and change these. So this is going to be MOVMSK, MOVMASK, PS. We've got register, so for the register I'll use RCX, I guess. And then so EVEX, oh, this only has VEX actually, so this goes to YMM. So I can just add a V for these ones. And then this can just be YMM. There's only two operands. So let's duplicate this and call this PD. And then we'll go and create these tests, like the test notation. Line it all up. So this is saying keyword. I think I'll change this to, should it be keyword or, no, it should be X word or Y word. So let's just change this to X word. And then these two here will be Y word instead. Okay, let's just go and get these mnemonics. We'll go and add them to the consts over here. Add them to the table. And then go and add them to the forms. So if we just fill out the PS one first. This is saying that it's passing. That must mean that I've forgotten to assemble. Okay, that's better. Okay, so for MOVMSKPS, we want to match on the width of X word. Op-N for this is RM. Op1 can be a register and op2 can be a vector. There's no prefix, but there is a map. And the opcode for this one is 50. So this only has VEX for this one, but it can match on Y word as well. Family VEX. Same thing, so I don't need to change anything there. And then this one is probably going to be basically the same. I imagine I'm going to have to set the W bit. No, I don't. It's just this one has a prefix instead. So let's just add the prefix. This is prefix 66. Let's just do the test. Okay, so we're getting incorrect. Okay, so that's because this XMM1, it does want keyword for this. I think I would still rather match on X word though. So for these two, I think we'll just say that enc width is keyword. Okay, that's okay. So that's MOVMASK. Then there's MOVNTDQ. So we've got MOVNTDQ here. This one is MR all the way down. So we've got MOVNTDQ. So legacy here is memory, then just XMM. Then we got the VEX encoding, which does XMM and YMM, and then EVEX goes all the way up to ZMM with no extra features here. So we'll do YMM for this one. So that's two VEX ones, and then we'll just copy these and do another one for ZMM. But to force the EVEX encoding for the other ones, I'll make sure to use a high register. Okay, let's just do the tests. So we've got X word, Y word, Z word. That all looks okay. Let's just regenerate the listing. Okay, so this is just two mnemonics. Okay, let's just go and add them to the forms. So we've got MOVNTDQ. This has a prefix 66, and this one is only matching on the width of X word again. Width X word, op N is op NMR for this one. Then we've got prefix. Op1 needs to be memory. Yeah, it's only memory. Op2 can be a vector. The prefix for this is 66. The map is the secondary one, and then the opcode is E7. So we've got one here for VEX as well. So VEX allows Y word. Other than that, it's the same. And then we've got EVEX, which allows up to Z word. Okay, so that's that one. Then we've got NT I. So this is just memory register as well. Let's just copy these ones here first, I guess. So we've got NT I. This one is just D word or Q word. So let's just do the forms this time. So we've got D word and Q word to match on. And they're both the same, so they can both be in the same form. So they've just got the secondary opcode map with no prefix. And then the opcode itself is C3. And they don't have a V version, so I'll just get rid of that. Okay, so let's just go and add the mnemonic. And then we'll go and add the tests to the assembly file. So this is MOVNTI, and here we've got memory then register. So memory will do RCX, and then register will do ECX and RCX. Okay, that looks all right. Let's just do the assembly and run go tests. So it couldn't match an instruction for this form. Op1 is memory, and we've got D-word and Q-word. D-word, Q-word, op1 is memory. Second op, oh, this should be register. Okay, that's fine. So next one is MOVNTPS. MOVNTPS is memory and then vector. So this one looks similar to, let's see, MOV. Do I have another one that does this? MOVNTDQ. This one looks like it's basically the same sort of like forms. So we've got vex, evex, and legacy. So we'll just copy these ones into here, I guess. Get rid of these tests. So this is MOVNTPS. MOVNTPS. We've got XMM, YMM, XMM up to ZMM. And then we've got PD as well. PD. So let's just go and get all of these and create some tests for them. Align them with each other. Okay, so let's just take these mnemonics and move them over to the mnemonics constants. And then we'll go and add them to the forms. So it seems like this is basically the same as the DQ one. So let's just go and just, I guess, copy this a couple of times. And we'll change DQ to PS, and then here we'll change it to PD. Yeah, so it matches all of them. Now it's just got the incorrect bytes. So PS here has no prefix, secondary opcode map to B. So for this one, we have no prefix, secondary opcode map to B. Then for PD, it's we do have the prefix, so we'll keep that, but this is also to B. So VMOVNT, this is probably EVEX needing W1. Okay, that's that. So then we've got VMASKMOV, which is down here somewhere. So here's VMASKMOV. These ones are all either RVM or MVR. So it goes, these ones are RVM, and they only go up to VEX for these. In fact, it's all VEX. And then these ones are MVR. So we'll just do these ones first. So we've got VMASKMOV, XMM 0, XMM 2, and then some memory. Then we've got YMM here. So this is YMM. oh, this is a VMASKMOV PS. We'll do the PS ones first. So we've got PS, PS, and then PS down here just has the memory operand coming first instead. So maybe we'll just do something like this. And then we have some for PD as well. So there should be 8 forms here, which there are. So we'll just do PD as a separate one here. Split these, get rid of the empty line, copy, put them in here. Do the transformation for the test, line everything up. Let's just check this over. I think this all looks okay still, so let's just do NASM. That seems like it's okay. Then let's just take these VMASKMOV mnemonics here, and we'll take them over to the mnemonics, deduplicate them. Let's just copy these down into the name table. And then add some forms. So go test should fail as usual. So VMASKMOV PS, we're going to match on X word or Y word. And the family is always vex in this case. So the width for this is X word or Y word. The op n for this initial one is RVM. So op1 is vec, op2 is vec, and op3 is always memory. This has a prefix of 66. It's got a map of 0F38. And then the opcode here is 2C. Then we need another one because the operand encoding changes around to MVR, which I don't think I have right now. But we've got MVR as the operand encoding here. So this one becomes memory, and this one over here becomes vec. Then we've got the same prefix, the same map. W is still 0, but this is 2E. So 2C and 2E. And then for PD, we've got 2D and 2F. So let's just copy these down into here. So these basically just go up by 1 each. I think I've got a syntax error somewhere. Yeah, here. And here as well. Okay, that's all okay. So I just need to add this new operand encoding, I think. Let's just go and add this in. So this is going to be case MVR. So this one is M is RM, V is VVVV, and then R is reg. So let's just do a test for this. Okay, that's all okay. So the final one I want to add is just actually a load instruction. So this is LDDQU, so this is load unaligned integer 128 bits. So these are all just RM, where the M operand is always memory. So let's go back to the tests over here, and we'll add it below here. So this is LDDQU. So this is always XMEM0 and then some memory. Then we've got the VEX encoded one. and that also supports YMM as well. Okay, let's just line all those up. That seems fine. Let's just add these mnemonics. And then we'll go and add the forms. Let's add them below here. Regenerate the listing file. Okay. So let's add the forms. We're basically always matching on, for the legacy version, matching on xword. Op_n is always op_n rm. Op_1 is a vec and op_2 is memory. Then we've got a prefix of f2. Map is the secondary one. And then the opcode here is OXF0. So let's just do, we'll do a form for the VEX version now. So this can be xword or yword, and the family is VEX. Okay, so that's all working. That's all I want to cover for now.